So, Eric, I'll just count us down and we will go. You ready?
Ready as it will be.
All right. In three, two. Hey, welcome back, everybody. Jeff Frick here, coming to you from the home studio for another episode of Turn the Lens. And we're excited about this next episode. You know, we've touched a little bit on some environmental areas. We've talked a little bit about sustainability. We've had the Clean Tech Council was on, and we've also done some stuff in robotics. So this is a really interesting kind of coming together of robotics in kind of an old industry solving kind of a nasty problem that's really better done by machines than people, because nobody wants to have this job. And as we learn in Dirty Jobs, there's a whole lot of crappy jobs that computers are just better to do. So welcoming in through the magic of the internet, I think from Oakland, California, just over the bay, not too far, he's Eric Law, the co-founder and CEO of Urban Machine. Eric, great to see you today.
Awesome. Thank you for having me, Jeff.
Absolutely. So why don't you just give us the 101 for people that aren't familiar with Urban Machine? What are you guys all about?
Yeah, we are a 2.5-year-old robotics startup that is building robots for removing metal fasteners from lumber. We take out the nails, the staples, the screws, and then once it's metal free, you can treat it like virgin wood. You can build with it again. You can use it in furniture. It's really a cool product once the metal comes out.
So how did you come up with this idea to use robots to pull nails, fasteners, and screws out of pieces of wood?
Everyone asks that question. What did you trip on and hit your head on, right? And this idea.
A screw or a nail, I'm guessing, probably.
Exactly. Smash my finger with a hammer. Yeah, so I've got about a 20-year career in construction and tech, and the last project I was doing was I built an innovation program for a large contractor, where we focused on bringing in robots to augment the craft. And we really looked for dull, dangerous, dirty tasks that are highly repetitive, and that's where the robots do really well, right? That high repetition is key for it, and it's tasks that humans aren't necessarily good at. And while I was there bringing these robots in, we started a sustainability project with a group of folks there. And we were looking at waste streams. And that's where I was learning, concrete and steel have recycle paths, but wood do not. Wood's going to a landfill, wood's going to incinerators because of the metal fasteners. It was just too expensive to get them out. And so that's concrete formwork, that's demolition wood, temp structures, handrail, just all getting ground up and going to incinerators and landfills. And so that was kind of the impetus for like, hey, this is a really big problem. It's about 37 million tons of dimensional wood here in the US every year gets thrown away.
Not a good thing. Well, let's back up a step on the robotics piece of it specifically, because you were in robotics before and they asked you to look for applications for robotics. And I think what's interesting is people get, I think, way confused by all the press with humanoid robots. And, at the NVIDIA show, recently Jensen had, I think, like 8 people looking robots, but the most successful robots don't look like people at all. It's a Roomba, that runs around and vacuums the house. It's the Amazon, ones that we see that are moving pallets around all the time. Clearly they've been in manufacturing and cars and stuff for a long time. So when you think about how do you apply robots, so you look at the problem first and you say, this is perfect for robot, because I think it's a different way to think about robots. And I think people that aren't in the industry tend to go straight to that humanoid thing and not really think about it's a machine that we can program to do tasks that it just does better than people if the attributes of the task are just right.
Yeah, the humanoids are cool looking at, and they scare a lot of people and they do some fun stuff and they play soccer. But at the end of the day, it's the task specific machines that rule the automation rule. You design a machine for a very specific task, and then you have it repeat that task, hundreds of thousands of times over and over. And that's where robotics are very successful today. If you look at auto manufacturing, right, you have a robot that puts tires on cars and tightens lug nuts or welds or, very task specific. And that's where the opportunity is, right? Those highly repetitive tasks. Humans are much better at problem solving, right? The majority of humans don't want to do the same thing over and over and over. We get bored. And so you find opportunities where there's high repetition, and the machines will do it, millions of times the exact same way over and over. And so all the construction robotics companies that we worked with, it was all specific. It was layout, drawing lines on the floor. It was drywall finishing. It was bricklaying. And the other thing we had to do too is there wasn't enough robotic startups in the space. So we would identify business problems on our job sites And we would go out and look for people to start companies and venture capitalists to back those folks to solve those problems.
Okay, so you found a huge opportunity in this waste stream. Like you said, the cement waste stream, there's some recycling going on there. The
Yep,
steel one is going on, but these
yep,
huge piles, and I think you said 37 million tons, is that right, per year goes into landfill, which is just shocking,
yep.
and a horrible a horrible big number. But the and again, I've listened to a few of your podcasts. Most of that stuff is from demolition or taking things apart. That's not the same as a robot putting a tire in the GM line. That's the same tire on the same nuts every time. You have like infinite variability of the crap that comes off these demolished buildings. So how did you start to really think about the problem, break down the problem of how you could take these really highly variable inputs and then
Mhm.
still have a process that you could have a nice output?
Yeah, so what we did is we looked at what's the repetition, what's that overarching theme that just repeats over and over, and that's the fasteners, right? That's the nails, the screws, and the staples, and there's a lot of them, right? Every 6 inches, every 12 inches, you can get a fastener in a board that was holding up drywall or plywood or whatever that attached material was. And so we said, let's have the humans focus on the non-consistent and non-high volume. So if you think about like electrical boxes and structural fasteners, those are low volume, but there are lots of different shapes and sizes. So in our in feed, we still have humans that take off those odds and ends. And then the machine takes care of the high volume, high repetition. And what we do is we actually normalize the material. So we cut all those fasteners down to make them little nubs. And then we cook them all to reduce the friction force. And then we pull them all out. So it's really about 4-step process coming to, and then the fifth is run it through a metal detector to make sure it truly is metal free for our customers. And that's the one quality requirement we have from the industry is there cannot be a nail left in that board. It's got to be metal free because otherwise it will destroy a planer blade or a saw blade. Virgin wood machines do really good with lumber and wood. They don't do well with metal.
With metal. And then in terms of the process, right, do you bring the tech to the material or do you bring the material to the tech?
Yeah, so we are focused on taking the tech to the material. Most of this material is collected at waste facilities. Sometimes people call them MRFs or material recovery facilities. And it's where all the contractors, whether it's demolition or concrete, all dump their trucks and trailers and bins full of wood. And so they've got the raw material for us.
And then you process it. So describe to us kind of the basics of what the line looks like, what the machine actually is that you would set up at that spot.
Yeah, so it's about 150 feet long. You start with some in-feed workstations for the crew, where they've got tools and workstations to help them clean that material and send it into the machine. And then the next, 125 feet is for the most part automated. Our machines are probably about the size of 4 refrigerators
Okay.
lined up, and each of these machines has its own step, right? So we got bandsaws running in the cutter one that's cutting all the fasteners. After it's cut, then it goes into the cooking station where everything gets cooked, and then from there it goes into the picking station. And it's really cool and impressive. And then goes through a metal detector, and if it dings, we still got metal. If it doesn't ding, it's metal free. So it's really a pretty straightforward linear process. And then out the other end, we have employees that sort the material.
And how many people to operate it?
Yeah, so it runs from 2 to 4.
2 to 4. Okay. It's just interesting because I think at least for laymen like me, I think we really started to see the reuse of the construction materials on site with cement next to freeways and stuff, because you can see it, right? It's not behind a fence where back in the day they would haul out all that cement away when they were redoing the highway, and now you see they've got this dedicated spot where they're running it through this grinder and basically putting that material back in place. So that's kind of a similar thing that we'll start to see for wood.
Yep, absolutely. So right now, today, all the wood goes through a grinder before they bury it. We're essentially going to replace that grinder. So all the long material, the high quality stuff that doesn't belong, either getting burned or buried, goes back to the job site.
And what are the economics that you have to hit to make it worthwhile? Because it seems pretty cheap and easy just to throw the broken stuff in the back of a truck and drive it off to the landfill in terms of expense and complexity from the developer point of view.
Yeah, so we have to compete with virgin lumber, right? So at the end of the day, the contractor or whoever's buying that wood makes a decision, right? Do I want the reclaimed material or do I want the virgin material that came from the forest? And so our target is to have a process that competes with a virgin log mill, right? So those are the guys in the Pacific Northwest or in the Southeast that go harvest the trees and process them and turn them into virgin 2x4s. The big advantage we have is we don't have the shipping because our source is right next to our customers, right? We're sourcing material from metropolitan areas. We clean it up in those metros and we sell it back to those metros. Whereas virgin lumber coming out of the Pacific Northwest, if you're going to Texas, you're going a couple thousand miles of rail and trucks to get that material to your customers, which is expensive. The other thing we don't have is we don't have the risk of a commodity. Lumber prices go up and down. As we saw during COVID, they went up
Right.
about 3.5x, which was a huge impact on housing prices because lumber is still the predominant building material for single family and multifamily residential. And so because ours is all locally sourced and we're not a traded commodity, we can provide consistent pricing to our customers. So we don't have those shocks.
And is the business model to provide the service that somebody else just continues to own the wood, or do you take ownership of the wood, or are you still trying to figure out kind of where's the business model in terms of who's paying whom to do what and what the ownership of the wood or the output is?
Yeah, so right now we're in the wood business. So all the material that we clean, we sell
Okay.
to really get the market going. Our long-term vision is to lease and sell the machines to customers that will then operate the machines in their local metro areas. They'll source the material, process the material, and then sell it back within their metro areas. Our goal is not to operate lots of wood processing facilities across the world because what's interesting is this is a global issue. Europe's got
Right.
the same challenge, Australia, New Zealand. Anybody who's built with wood has massive amounts of wood waste.
And I think it's what's in Australia that I think Atlassian's building like the largest wood skyscraper
Oh, really?
as a new headquarters. I'm pretty sure. I have to double check the facts, but I think so. Because I think in a couple of the interviews you talked about, people talking about doing more with wood,
Yep.
as even a replacement for steel and concrete and in more applications. But I think that's pretty interesting. Let's shift gears a little bit and talk about the robots and robotics. It's especially there's all kinds of interesting kind of robotic processes that you have to put into these things in terms of being able to see the nails and being to adjust to the nails and treating a nail different than a screw and angles and this and that. I wonder if you could share some of the challenges and also some of the advances that you've seen in your career in robotics as motors get smaller and the horsepower that you get with the computing power that you get. I mean, it's a whole different world than when you started in robotics a while back.
Yeah, it's a couple major advancements. I mean, obviously, the cost and power density of motors is phenomenal, right? We don't run any hydraulics. Historically, the lumber industry does everything with hydraulics to get their power performance ratios. We don't. We have no hydraulics on our systems. We have a little bit of pneumatics for a couple operations, but it's mostly all electrical drive, which makes it really efficient to move material, gives you incredible control and accuracy over the material. And then the other one is computer vision. We're using cameras. Our system is full of cameras to take pictures of the wood and to identify fasteners. And so when we look at the advancements in computer vision and AI technology, we're leveraging that to solve a real problem, right? We're not Bitcoin or any of the other fun AI projects that have humanoids running around. It's like we're using AI to solve an industry problem and a waste problem, which is awesome to see it get put to use.
Yeah, that's great. And I saw I saw one interview that you had a couple interns on. So I wonder if you can share a little bit about what's going on in kind of academia and robotics. I mean, robotics seems like such a cool industry that brings together all these different specialties. I know you were a mechanical engineer, how you got in it, which is probably the more traditional, but there's opportunities for software people. There's opportunities for human factors. I mean, there's so much going on in robotics. As you take a step back and look at that industry as an opportunity for people to think about either an existing career or a new career, what gets you excited about the future of robotics?
Yeah, it's probably one of those few industries where you're combining multiple expertise to actually solve the problem, right? It's hardware, it's physics, it's software, it's computer vision. There's a lot that goes into these machines and getting these machines to market. And we do research with local universities. We've had interns on our team. Probably have some more this summer as well. And then not just the robotics side, but also the sustainability side, right? So okay, we got robots that process this material, but how do you sell it back into the market, right? Who's the customers? What do they do with it? What's the process? What does that demand look like? Because we're connecting 2 points in the economy that have never been connected before, right? The waste industry has never sold wood to the lumber industry. And so we're making those connections. So in order for our robots to work and be successful, we have a sales team and a marketing team that's driving that demand. And so it's a huge team effort to get this shift going, and not just the tech, but also the market side as well.
Right. Well, let's talk a little bit specifically about the carrot and the stick in sustainability and governance, because I've seen, you speak at a number of different conferences. You speak at building conferences and materials conferences, but you're also speaking at sustainability conferences. And clearly, the role of governance and the changing of laws, either to hit sustainability targets or to have requirements, especially in buildings, changes things pretty dramatically. So where are you seeing, kind of the tailwinds from a governance point of view that's helping you? And how is the market kind of responding to both kind of the carrot side and the stick side of just not throwing stuff in the garbage?
Yeah, there's really two drivers there, right? There's the demand side where people are looking for more sustainable building materials, right? They're looking at their carbon footprints, they're looking at the waste from those materials, where are they sourced from? They want local over long haul materials, which really aims you at reclaimed lumber, right? If I can source material from my new building, from an old building down the street, that's a huge win on sustainability, and it's a great story, right? The designers really like that. The other side is the waste problem. So as we started to dig into it and learn more about the waste industry and who owns it, typically the government agencies are responsible for the landfills and disposing of waste within their regions. And nobody wants to build a new landfill. Over the next 60 years, all the landfills in the US will be full. And it takes about 20 years to permit a new one. And so nobody wants to go down that path. It's massive expenditures. It's not politically, nobody wants to fill up a canyon or fill a hole in the ground. And so what we're seeing from these government agencies is different legislation to keep material out. And wood is one of the biggest contributors to landfill space by volume. The concrete's not going in, the steel's not going in. So when you look at buildings, it's the wood. And so there's deconstruction ordinances, there's source separation ordinances, there's incentives not to bury the wood economically. And there's a lot more of these that want to get passed. But the challenge is, what do you do with all this wood? Okay, if we don't put it in the landfill, what happens? Well, we chip it and we burn it. Oh, okay. That's not much better, right? And so we're the first ones that are bringing the technology to market that says, okay, let's take as much of this wood as we can that's still dimensionally intact, and let's use it in the buildings again. Let's go store this carbon in building walls, right? Which is a great place to store carbon, because I can store carbon and I'm housing people, which is a huge win. That's way better than storing it in the ground or whatever some of these other schemes are to manage it. And so that's our goal, is to keep it back in circularity and let people build with it again.
And you said most of that's being driven at the municipal level because they're the ones on the hook for the landfill?
Yeah, so that can be cities, counties, metropolitan government agencies. It kind of depends on where you are. We've talked about a whole host of different people who host that problem.
Right.
States are getting involved in it. We're seeing state funding coming down, federal funding coming down. We've had some agencies receive federal funding to go rent our machine and set up reuse facilities in their metropolitan areas.
Interesting. I want to shift gears and talk about something you've discussed in other podcasts, which is changing people's behavior without really trying to change their process too much, right? It's hard to get people to change their process, right? Everyone's stuck in their ways, but there's also, kind of precedent processes and subsequent processes that are all tied together. So to interrupt that or to get people to change, a step of that is very, very difficult. You made a really interesting comment. You're trying to do it without actually changing anything. And I wonder if you can share, some of the techniques and how you approach it. And I saw one interview that you had, a local wood guy that had his own mill who, clearly was a little innovative and willing to take a chance and try something new and had open eyes and open ears. But how are you addressing this very old marketplace with a lot of old players and a lot of established ways of doing things, and you're really kind of trying to change it up a little bit?
Yeah. So if we start with the waste industry, right, which is our source, right? So how can we minimize the impact to them while adding financial incentive? So right now today, typically they minimize the wood, they sort the wood out, they smash it all up into wood chips, and they burn, bury it. Maybe a couple of them are selling it for some landscape products. And so our goal there is how do we source that material from them and incentivize them economically? The good news is they're used to recycling other materials, right? They grind up concrete and sell it as base rock. They take the steel and they go to the scrap guys with that. And so they're used to trying to convert waste into a high value or valuable commodity. So when we pitch them, they're like, this is very interesting, right? We're very interested in selling this as a commodity, truckloads of wood going off our facilities. And some of them are at risk of losing their wood chip customers because burning wood chips is losing out to solar. It's interesting how all these things work. When you start to learn about these industries, it's like, wait, the incinerator guy that's burning the free wood chips that you're giving them can't compete with solar. And they're like, no, the operating costs on the wood burners are just getting crushed by the solar panels. Because once you put out solar panels,
Interesting.
you
I
know,
never
you got
heard
to do
that
some,
before.
yeah, a lot of these guys are shutting down. And so we actually had a couple of people introduce us to the term woodmageddon. And if they don't have a place to burn these wood chips or bury these wood chips, what do you do with them? And so right now we're one of the few options available besides burning and burying them. So it's nice to have the right timing, I would say, right, and have these pressures. So for the waste world, they're very open to it. They're like, if we can make money selling our wood instead of grinding it and giving it away, that's a win for them. And then on the construction side, the great thing about lumber is the dimensions have been pretty consistent, since about, I believe it's the 1940s, when they went from rough sawn to this finished 1.5 inch, 3.5. And so as long as we get it metal free, any virgin lumber mill can process it. And so we can sell them lumber just like they procure it from an existing log mill. And so as long as we can sell them a material that acts like, looks like, measures like their existing material, there's very little change to them. And then they get to sell it as a greener story. We went and got our FSC certification, so it can be FSC reclaimed lumber. That's a big win for them. And then a lot of folks are looking as, hey, this product looks and sells just like my other products, but it makes me look better and I can market it as a more sustainable material. Ooh, that's a win too. And so that's our goal, right? How do we add that value to our customers that outweighs the small risk, or how do we minimize that risk as much as possible? And so it's awesome to have these first adopter partners to go validate that with and go demonstrate that says, hey, here's material, we're selling it through your company, here's your customers, it's running, they're building it, they're taking pictures of it, and it's working.
Wow. The Woodmageddon, that's funny. Because another one of your interviews, you mentioned that 37 million tons, if I'm getting the number right, is basically half of the new wood shipped by the lumber industry in the US per year. Did I get that right?
Yeah, for softwoods, it's about half of what we harvest from our forests for softwoods.
That's crazy.
Yep.
That's absolutely bananas.
And we produce a
Um,
lot of wood here in the US, and we import a lot of wood.
So let's talk about wood for a minute, because I'm sure there's going to be a couple of people that are going to stumble upon this just to talk about wood, the quality of wood, the change in wood and wood construction. And we know, back in the old days, there was a lot more old growth that was taken down. There's a lot of old redwood that's out there that people just treasure. What do you find in this process, and what's kind of the uptake and the opportunity just from a pure, kind of the wood that was in the buildings, that you just can't get wood like that anymore?
Yeah, I mean, that old growth stuff, your only option is a building, right? You can't go out to the forest and cut down old growth trees anymore. And so you got to do it from a building. And those buildings are holding a lot of material, right? Despite, our average buildings here in the US are somewhere between 30 and 50 years old, probably. Despite that short lifespan, especially here on the West Coast, there's still a lot of buildings out there that were built prior to the 1940s that have old growth, rough sawn, truly 2x dimensional lumber in them, with really tight grains. And it's beautiful stuff. When we get that stuff, it flies off the shelf. The designers love it, because it's unique, right? There's not a large volume, and traditionally is really expensive material to get your hands on.
Great. Want to shift gears a little bit and just talk about labor and talent and trades. You mentioned in a number of your interviews specifically, we're not taking out high skilled craftsmen and tradesmen, but I would imagine in the construction industry, like in every industry, labor and talent period is a problem and is only going to get worse, unfortunately, going forward. So, when you think about in terms of the talent and just getting people, what does your solution, or does it really help them along those lines? Is it an alternative way that they don't need as many people? Is this a great way for people to expand into different areas within the industry? How do you fit within kind of the whole labor tightness story?
Yeah, so ironically, we actually are adding labor with our machines because we need people to feed them and take it off the outfeed. And there's nobody doing this today at scale, right? Traditionally with robotics, mostly in construction, we looked at augmenting labor, right? How do I reduce the number of labor hours I need on a job site with a machine? And this has obviously been going on for, over 100 years with automation and Caterpillar tractors and stuff, and now it's robotics. But for us, we're actually bringing a machine to market that's actually going to increase the demand for labor. So our machines, they take about 2 to 4 people to operate, so not a huge amount. But what it does is downstream is it feeds a local manufacturing base, because now you've got a raw material in metropolitan areas that you can feed into wood manufacturing companies, which is a great opportunity. So we've actually had quite a few municipalities reach out to us where they're like, hey, we've got these old blighted homes and buildings. We'd like to take these down, but we want to turn them back into local buildings, and we want to do some job force training, which our machines work out really well, right? You get to put people in a manufacturing setting processing lumber. They're not doing the nail pulling. They're operating the robots and the machines and maintenance on machines. So they're higher skilled jobs than pulling nails and fasteners. So it's really cool to be bringing in tech that's actually going to put more people to work solving a sustainability challenge.
And are the machines that you're shipping today, just give us I should have got this earlier, kind of where you are in terms of the lifetime of the company. I think you ship like 4 or 5 machines, if I recall from some of the other interviews, probably off date. Are these, kind of production prototypes? Are they scale machines? Are they in a position yet to get the scale that you're going to need to really make them hum? Or are you still working out a couple of the kinks?
Yeah, so we have shipped 2 R&D machines. We had one that went out May of last year. That started field trials, ran for about 4 months before we swapped it out with the next version. The current version that we're running right now spent 3 months at a large waste facility in San Jose that did a pilot down there. Then we moved it up to the lumberyard in American Canyon that we've been based out of for our field testing. And it's been running up there. So it'll be 9 months old almost that the system's been running. So it's pretty cool to see this one running. And then we have one more iteration on the tech. And this next iteration on the tech will be the hardware that will ship to our first customer in October. So it's nice to start to transition from the R&D. R&D is great, but it's expensive.
Right.
And into shipping units to customers. And that one will head up into the city of Seattle in October.
That's great. So what was kind of the biggest learning of moving from the lab to the prototypes out in the field?
Yeah, it's
unexpected learning, I should say.
It's these manufacturers and they give us these specs and they say, oh yeah, they operate in these temperature ranges, and you start loading the hardware and you start putting the pressure on it and it starts failing.
Then your components, you mean the components that make up the machine?
Yeah, we went through a lot of components, was a big learning one. The computer vision, we started with 3D depth sensing cameras, and unfortunately they haven't performed as well as we needed them to. So we've actually taken a step back and brought in 2D cameras, which cost less, but are performing way better. And even in our environments, they're performing better. So it's going back and using some more proven technology, we'll call it. But the system that we're building in the shop is just screaming fast compared to the last iteration. And the last one's doing great. So it's pretty cool to watch those iterations and the tech evolve to the point where it's like, okay, let's get ready to ship this one to a customer.
And what is fast? What are you measuring? Fasteners removed per unit time, or board feet through the machine, or what are some of your measures that you're working towards?
Yeah, so internally we do fasteners per second coming off the machines, board footage moved, linear footage moved. We do everything in metric on the engineering side, but on the customer side, everything's feet and board feet, right? And then for the customers, it's a board footage range.
Okay.
Our target is to move, 2,500 to 7,500 board feet per shift with the system. So that'll run you about, was that? It's about 500,000 to 1.5 million board feet per year coming off that system. If you run one shift, if you run two, you just doubled it. Is really the economics. And what that does is it puts us at price parity with virgin lumber mills. So that gets us down in that 40, 50 cent a board foot market so we can compete head to head with them.
That's great. That's real. Those are big numbers. So let's shift gears one more time before I let you go.
Yeah.
And this I found fascinating. And in all these podcasts I was listening to you, at the end, they always say, right, how can people get a hold of you, Eric? And rather than saying, go to Urban Machine, what is it? Do you have a funny dot what?
Build.
Build, urbanmachine.build. Maybe that's too hard. You say, go to LinkedIn, and you're all over LinkedIn. And you even say, we're talking about our products on LinkedIn. We're, communicating with our community on LinkedIn. And I just thought it was interesting. I wouldn't necessarily think, because I think there was another interview you said, not necessarily everyone in your construction world is in LinkedIn. So I'd just love to get your take on how you're using LinkedIn, why you're using LinkedIn this way. I'm obviously a huge proponent myself, but one of the requirements for it to be effective sometimes is if your target market is actually swimming in the same pool, and if they're not in the pool, it's kind of hard to communicate. So share a little bit about your strategy with LinkedIn and its effectiveness.
Yeah, so it's interesting, trying to find where is your market, right? Where are these people congregating? Where are they working and sharing information? And it turns out it's LinkedIn. That's where the contractors are, the architects are, the engineers are. The waste industry, they're working on it. And most of them aren't on LinkedIn. It's a good old fashioned phone call to get to those folks. But for sustainability, the design world, the construction community, they're all there. And so Jory, who heads up marketing for us, has been very active on there with building that community of followers. And we have super fans. We went and visited a waste facility last week, and we got to meet one of our super fans there. She just recently joined their team, which is cool. It's like people have been following us and supporting us. When people see the machine running, they're rooting it on to pick fasteners, which is very cool, right? To be in a space where, hey, you're solving a problem and people like it. Right? There's nothing bad about this story about reusing materials to build again. It's a great story. It's a great piece of technology, and it's something we desperately need. We got to stop throwing away these high quality materials and get them back into the buildings.
Well, especially if we're throwing away half of what we're shipping in fresh every year. That's gonna not work very long. Yeah. That's crazy. So what have we not talked about, Eric? What have we not talked about that we should have talked about, because you're the expert and I'm pretty new to this whole space, but I think it's super cool. I love the sustainability angle, and I love the tech angle as well.
Yeah, I mean, we've covered the tech, we've covered the sustainability, the construction industry, the engineering side of it. It's cool. The history of the company, it's a lot of work. We got a really sharp team that's cranking away at designing, building, and testing these machines. We are 15 people, so it's not a tiny team here based out of Oakland, but we're making great progress, which is awesome. And we really appreciate opportunities to come and share that story with folks like yourself and spread the good word.
Yeah, well, it is a good word, and it's exciting on a lot of fronts. And again, I think the robotics angle is so cool. I think the AI angle is so cool. You got so many different technologies in this robotics, between the computer vision and all the mechanical stuff. I think it's a great story, and at the end, you get this beautiful product and keep it out of the landfill. So what's not to love? All right, Eric. Well,
Absolutely.
thank you for your time today. It's really a cool story. Glad to learn more about it and expand my knowledge a little bit on the robotics side beyond Roombas and Amazon warehouse robots. It's good to see them doing other things besides just moving stuff around.
Absolutely. Thanks for having me on, Jeff.
All right. Thank you. All right. He's Eric. I'm Jeff. You're watching Turn the Lens with Jeff Frick. Thanks for watching. Thanks for listening on the podcast. We'll see you next time. Take care. All right. That was great. Thank you.
Awesome, Jeff. That was great.